So now this video discusses about the Kirchhoff'S laws. So what are the Kirchhoff'S laws? So before we go further much in details with the Kirchhoff'S laws, I'd like you to understand about or recall much about the actually types of circuits. We have what you call the series circuit. We have what you call the series circuit, and we also have what you call the parallel circuit. So these are actually basic two types of actually electric circuit. And what is a series circuit? In a series circuit, it is the actual circuit in which all components are connected in a single wire. There's no junction in the series circuit. For instance, let's say we have this kind of a circuit. Let's say this is the case. And I would call, let's say this is resistor 1 and this is resistor 2, and let's say this is resistor 3, and let's say this is the actually a potential difference. I should say this is the battery or cell with some potential difference given as V. So this is a typical series circuit, and according to the principles behind the series circuit, you should have to understand that the flow of the current in the circuit at each and every point, the current is the same. So which means the current across R2 resistor is the same as the current across R1 resistor, and also the current across actually R3 resistor. And that is to say the current across R1 resistor, it is the same as the current flow across R2, and it is the same as the current across R3, and which is the same as the total current flow. And basically this is true for actually, and this is true for the series circuit. And also one thing you have to understand is that it is the only voltage which is being shared, in the sense that the voltage across R1 resistor, it is calculated using the Ohm's law, and that is using the Ohm's law we have the current flow times the resistor 1, and we also have the voltage across R2 resistor, that also being the same way, the current flow times resistor 2, and also do the same with the actually R3 resistor. So those are the facts or the principles behind the series circuit. At each and every point, the flow of the current is the same. So the current from the battery, the current flow from the battery, it is the same at each and every component. Only voltage is what is being shared. So what is a parallel circuit? Now in a parallel circuit, that's where we have more than two wires actually connected in our different components. Let's say we have this typical actually a circuit, and which portrays the parallel circuit. Let's say we have this case. And let's say we have, as this is the circuit. Now let's say this is resistor 1, and this is resistor 2, and let's say this is resistor 3, and this is the voltage from the battery. So now this is what we call the parallel circuit, and there is a presence of a junction. So the presence of a junction itself shows that the circuit is composed of more than actually two conductors. And this is also another junction of interest you can look off. So according to the principles behind the parallel circuit, voltage at each and every component is the same. So voltage at each and every component is the same, in the sense that, but there's one thing you have to understand about this kind of a circuit. Resistor R1 is in a series with the battery itself. So which means you should have to understand that the voltage across actually R1 is not the same as the voltage from the battery, because these two are in series. So which means across R1 resistor the voltage will be different with this one. And all you need to understand is that the voltage that is flowing in this circuit, it is flowing from the battery, and that is, you should have to get it that we will have it as, I should say, the current which is flowing in the circuit, it is the current flow from the battery. So which means it is going this way. So in this case, what you have to understand is that the voltage across R1 resistor will be calculated using the Ohm's law. That will be given as the voltage across R1 will be given as the current flow times resistor 1. And the current flow itself, it is the total current. So that is to say, in order to find the voltage that is going into these two resistors, what you have to understand is that we'll have to subtract, we'll have to subtract the total voltage minus the voltage across R1 resistor, and that voltage will be the voltage flow to these actually two resistors, and that voltage will be the same because these two resistors are actually in parallel. So you have that. So in that case, since these two are in parallel, then the voltage will be the same for all. Then now with that voltage you'll be able to find the current across here and the current across here. That you'll be able to have it in that way. So that's how you should have to understand about the simple circuits, that is the series circuit and also the parallel circuit. And I've just done this to remind you about some of the basics you have to understand about for the series circuit as well as the parallel circuit, and these are said to be the simple circuits. So why are they said to be the simple circuits? Why parallel circuit and also the series circuit are also said to be the simple circuits? Now the essence behind is that they all contains a single source of a power. That is, they all contains the single source of, I should say, the voltage. They all contains the single source of the voltage. Keep that in mind. So what if we have a compressed circuit? So if we say a compressed circuit, it is the circuit that you cannot define whether it is a series circuit or parallel circuit, and from the fact that it may have either two or more source of, it may have either two or more source of power. In other words, it can have two or more actually batteries. So how can you be able to analyze that particular circuit? What did you say? Now that's where the concept of the Kirchhoff'S laws has to be applied, and that is for the compressed circuits that you cannot apply, that you cannot actually analyze using the concept of the simple circuits like the series circuit or the parallel circuits. So that's where now you should have to understand about the Kirchhoff'S laws. So understanding of the Kirchhoff'S laws has to begin with those of the basic circuits like the series circuits as well as the parallel circuits. So what is the Kirchhoff'S laws? So there are two basic Kirchhoff'S laws you have to understand. We have what you call the current law. We call it as a current law, and it also known as the junction law. It also known as the junction law. And we also have what you call the voltage law. The voltage law, and also known as the loop law. It is said to be the loop law as well. So another name for the voltage law is said to be the voltage law. So now what are these laws? Here we go. Let's start with the current law, or we call it as a junction law. Now, according to the Kirchhoff'S current law, it argues that, let's say we have a circuit, and one of the part of the circuit is a junction. Let's say this is the junction, and where actually three conductors are meeting at that point. Now, let's say there is a flow of the current towards this direction. Let's say that is the case, and I'd call it this one as current 1, and at this point the current 1 will be shared in two directions. One part of the current will either flow towards this direction, I'll call it as I2, and another part of the current will flow towards this direction, and I'll call it as I3. So according to the current Kirchhoff's law, it states that assuming that the current entering the junction is positive and the ones leaving the junctions are negatives, at the end of the day, the summation of the voltage, actually the summation of the current at the junction is given as L. That is to say, I1 minus I2 minus I3 has to be equal to 0. This is according to the Kirchhoff current rule, and it can be given as the summation of the current at the junction is given as 0. That is by having the current leaving the junction being given as negatives, and the one entering the junction being given as the positives. At the end of the day, there is actually a summation of at the end of the day, the summation of the current at the junction is given as L. And we can use the analogy of the flow forward. It is the same. Let's say we have, this is a pipe. Let's say this is the pipe, and let's say the pipe is now divided. Let's say the pipe now has been divided into two segments. Let's say this is the water flow. I'd say this is, let's say, water 1 that is flowing in the main pipe. Upon reaching here, the water will be divided. That is to say, we'll have some water flow in this direction. I'll call it as water 2, and some water will flow towards this direction. I'll call it as water 3. So at the end of the day, you have to understand that the summation of the water flow in pipe 1, in pipe 2 as well as the pipe 3 will be the same as the water entering the pipe. So that is the principle behind the voltage. That's the principle behind the Kirchhoff a current rule. It states that the summation of the current at the junction is given as L. Now here's the question for you. Actually, a Kirchhoff current rule, it is said to obey the conservation of, it's said to obey the law of conservation. So why is it that the Kirchhoff a current law, it is said to obey the law of conservation? I want to see the responses in the comment section below. Now let's proceed. And for instance, let's say we have a junction. Let's say we have a junction where we have actually two currents entering. Let's say this is the junction. It is possible sometimes to have a case where we have a junction and having two or more actually currents entering that junction. What would we say? Let's say we have, this is a junction. Let me have it this way. Let's say this is a junction. This is the junction in that way. And let's say we have the current. Let's say this is the I1 entering the junction. And let's say we have another current, let's say I2, entering the junction, and we have another current, let's say I3, leaving the junction. So what is this according to the Kirchhoff's the current rule? Now this one will be given as I1 plus I2 minus I3 will be given as out. That is according to the Kirchhoff, actually. That is according to the Kirchhoff, the current rule or the junction rule. They come up with a case whereby we have, let's say, we have three actually currents flow towards the junction, and let's say one current flowing away from the junction, and come up with Kirchhoff actually a current rule from there. That is, if you can. Now let's proceed with a Kirchhoff voltage law. Now, what is the principle behind the Kirchhoff voltage law? Let's say we have, mind you, a Kirchhoff voltage law is also said to be the loop law. Let's say we have a loop. If we say a loop is a complete circuit, it's a complete closed circuit, that is a loop. It is more or less like a window, it is more or less like a window. So a loop can be given as a window or complete closed window, that is said to be a circuit. Let's say we have this case. Let's say this is another resistor we can have. And let's say this is resistor 1, this is resistor 2, let's say this is resistor 3. And let's say this is the voltage. Now let's say the current is flowing in this direction. Let's say this is the current I1. Actually, it should be just a current I. So since this is the series circuit, you should have to understand that the current across here is the same current across here, is the same current across here. But the only voltage will be shared. Now for this case, let's say the voltage across I1, it is now to be given as, I'd say, VR1, and the voltage across here, it is VR2, and the voltage across here is given as VR3. Now what is that voltage which is being shared? Now the voltage which is being shared, it is the voltage from the main source. So which means, let's say, if the main source is having, let's say, 20 volts, let's say the main source is having 20 volts. So let's say R1 is more resistive. It will consume, let's say, about 10 volts. And let's say R2 is, let's say, consuming about 5 volts. So which means from 20 we are now remaining with 5. Then the other remaining 5 will be consumed by the resistor actually 3, who have 5 volts. Now from this actually, now you have to get it that from this resistor, now you see that all of 20 volts has been used up, so there's no any other voltage remaining. So at the end of the day, you have to get it that the summation of this voltage and this voltage here is the same as the total voltage. So if that's the case, let me get it in this way. So the summation of the voltage R1 plus the voltage across R2 plus the voltage across R3 is the same as the voltage from the battery, that is given as V. So this is the same as VR1 plus VR2 plus VR3 minus V is equal to 0. This is what we call the Kirchhoff voltage law. It states that the summation of the voltage in a loop is given as 0, and this is for a given loop. Summation of the voltage in a loop is given as actually 0. That's what you call the loop law or the voltage law. So those are the two actually Kirchhoff's laws. You should have to much understand about. So mathematically it is given as the summation of the voltage in a loop is equal to 0, as you have seen it before. Keep that in mind. So what are some of the things you should have to be in mind? And what are some of the things you should have to be keep in mind in the context of the Kirchhoff'S laws as well? So first thing, you need to identify the number of, you need to identify, first thing you need to identify, the number of voltage sources. So this is the very important thing to understand. Voltage sources. So for each given circuit, and basically you do have the voltage source. So you need to identify the number of voltage sources. And I also need to identify about the number of loops. So you need to know how many loops are in the circuit. That will help you much about. And the direction of the current. Now in this case, if the direction of the current is not given, you need to give it on your own. That is, if the direction of the current is not given, just have to give it on your own. And also a battery polarity. So battery polarity, we mean a positive terminal or negative terminal. Now let's talk much about the battery polarity. Let's say this is the battery. You should know that this is the positive terminal and this is the negative terminal. Now whenever the current is flowing, now for this case, when the current is flowing, when the current flow is let's say from a positive terminal to negative terminal, it is a voltage drop, and it is given as the negative voltage. And likewise, when the current is flowing from negative terminal to positive terminal, that is a voltage gained, and it is given as the positive. So you should keep that in mind. You should have to keep that in mind. And also on the same case, if in a given loop there's no source of the voltage, then according to the Kirchhoff voltage law, it is simply add up to 0. Let's see on how we can be able to apply those in the given problems below. So now let's say this is the circuit, and the question says find the current across each resistor using the Kirchhoff's laws. So by the way, this is a part of the complex circuit. As you can see, we have more than one source of voltage, or say source of power, of course. Now this is also part of the complex circuit. You should have to know. So how should we go over this? So now first thing, you need to identify the number of loops. So this is the loop 1 and this is the loop 2, as you can see. And the next, have you been assigned the direction of the current in the loops? So there's no any direction of the currents that has been given. So instead, you give it on your own. You may think of having an interest towards a certain actual junction. Now let's have this as the junction of interest. So at this junction, let's say we should have the current, let's say I1. We should have the current I1 and are flowing towards the junction. Let me have it proper here. Now this is happening because the currents are not being given, so you give them on your own. Now we should have, this is I1 flow towards the junction. I1 flow towards the junction, and let's say we should have I2 flow away from the junction, and also we should have, let's say, I3 flow away from the function. The next, we should know that the current flow in the first loop, it is I actually a 1. Now I'll have to indicate it in this way. So this is the current flow in loop 1. I'll call it as I1. And in loop 2, this is the current flow as well, given as now I3. So in loop 2, the current which is flowing, it is given as I3. And I2, it is the current flow along in this junction. I should say I2 is flowing in this middle branch. Actually I2 is no longer flowing in a specific loop, it is flowing in this middle branch. So don't confuse things there. So I1 is flowing in the first loop, and I3 is flowing in the second loop, and likewise I2 is flowing along the middle branch. So here is what is happening. We assume that I1 is flowing from here. Say it is flowing from here all over. Now this is a series part until it reaches here, and I2 is assumed to flow from here and all over here. This is the series part and enters here. Now on the middle branch, we have two currents that are flowing. So we have I1 that is flowing, and we have I3 that is flowing. And the I1, actually I2, which is the middle flow current on the branch, it is calculated using what you call the Kirchhoff's current law, in the sense that, as you can see, using the Kirchhoff's current law, we'll have it as, I1, that is the current entering the junction, minus I2 minus I3 is equal to 0. That's what is happening there. That's what is happening there. So anyway, we're going to see actually by the end of this example. We'll appreciate how it is working there, but just have to know that at the junction here, we'll apply the junction law in order to have, let's say, current I2. Anyway, let's proceed. Now we have the current flow across loop 1, that is I1, and that of loop 2, I3, and on the middle branch we have I2. Let's proceed. Now, how many loops are here? We have 2 loops. This is loop 1 and this is loop 2. Then let's see start. Here are the procedures that you have to follow. What is the current flow in loop 1? We have indicated as I1, a closed bracket, in that way. I should say open bracket rather, should be that. Then how many resistors that are in loop 1? In loop 1 we have resistor 2, or have it as 2, ignoring the units. And we have resistor 5, that is plus 5. As you can see, we are done with the resistors there. We are done with the resistors. The next, out of these 2 resistors, do we have any resistor which is being transversed by the current in the another loop? Do we have any resistor which is being transversed, or whose, I should say, do we have any resistor which is being transversed by the current from the another loop, we have it as resistor 5. We'll have minus, a 5 times that current from the another loop, giving us I3. Now our interest is to have the current. We are looking at the current that is flowing on the actually 5 ohm resistor from the another loop, not this of I2, no, but from the another loop, which is I3. We are done. Then is equal to, then do we have the source of voltage in that particular loop? Yes. What is that one? 10 volts battery. Now let's look at the properties of the battery and with respect to the direction of the flow of the current. So I1 flows from negative terminal to the positive terminal, and that is voltage gained. So have it as equal to 10. Ignoring the units. Please keep it in mind. Ignore the units. Then we'll sum up this. In this case, we'll have 7 I1 minus 5 I3, and which is equal to 10. So these three parameters are known parameters. Hence, this is regarded as equation 1. Keep it safe. That is equation number 1. We should have to keep. The next, let's go in loop 2. What is the current flow in loop 2? We have it as I3. Right? What are the resistors that are found in loop 3? We have 5 ohm resistor, which is the same because it is also part of the loop, the actual loop 2. And we have 30, ignore the units, plus we have 6. And out of these 3 resistors, do we have any resistor which is being transversed by the current from the another loop? In other words, do we have the middle branch resistor? Yes, that is 5. We have negative, and this is mandate. We have 5 times that current from the another loop which is transversing through that one. We have it as I1. We are done. Then is equal to, do we have any source of voltage in the loop? Yes. What is that? A 12 volts battery. Now let's look at the properties of the battery with respect to the direction of the flow of the current. So in this case, you see that the current flows from positive terminal to the negative terminal. Now that is the voltage drop. We'll have it as negative, actually 12. Ignore the units of the volts there. Then now we need to simplify this. That is 11 plus 30, that is 41. So we have 41 I3, and the minus 5 I2 should be I1, and which is equal to negative 12. Now this is given as equation 2. Now you can see that we have two common unknown variables for each equation. Then what you have to understand about is we are going to solve for I1 as well as the I3 using the simultaneous equation. And of course, what is the another equation you have to understand? Another equation is from, now this is the voltage law, also this is the voltage law. Now what you are remaining with is the current law. Now this is the junction of interest. You can see that I1 is entering the junction, and the I2 and I3 are leaving the junction. Equal to 0. This is equation number 3. So solve equation 1 and equation 2 for I1 and I3 simultaneously. Then upon having I3 and I1, substitute here and solve for I2. So current can be negative or positive. So if you have the negative current, it's not the wrong answer, only that the direction was supposed to be the otherwise. So the current can be negative or positive, no problem. And you work out with that negative value, no problem. Can be negative or positive, only that if you have the positive solution, it means that is the direction it was required. If you have the negative direction, actually, if you have the negative current, it means the direction was supposed to be the other way round. So keep that in mind. So in this case, you'll be able to solve it on your own. So you solve equation 1 and as well as equation 2, that is simultaneously, and having that one, you substitute into the equation 3, and I only to solve for actually I2. That's how you should have to get it up. Now there's something you have to understand. I1 is flowing in a car, actually in a loop 1 from here or over up to here. The current flow is the same as I1, so which means the current across actually 2 ohm resistor, it is the same as I1. You can be able to find the voltage across this using the Ohm's law. You can be able to find the power across this, whatever you want. The current across here is the same as I1. Whichever the point within this section of the wire, the current flow is the same. Likewise, from here or over here, the current flow is the same as I3. So which means 30 ohm resistor I3, 12 volts battery I3, 6 ohm resistor I3. This is the series part of the circuit. Now, how about the current flow across 5 ohm resistor? It is given as I2, that you are going to calculate from this. So keep that in mind. Now what if we have this actually a case? Now before I proceed, sometimes you can be given, let's say, the current across the middle branch. So if you have the current across the middle branch, it means automatically that is given as I2, that you substitute here, then be able to do whatever you want. And that could also simplify the work. Anyway, let's proceed with another example you can have. What if we have this circuit? So now let's say this is the circuit. Let's say we have this particular circuit, and that is the circuit of 3 loops. You know, we have, this is loop 1, loop 2, let's say this is loop 3. And in this case, these are the junctions of our interest. So these are the junctions of our interest. So let's see on how we can be able to calculate the labeled currents if this is the case. But one thing you have to know and understand is that I1 is flowing towards this direction. Of course, at each and every component, that is the current flow. I3, it is flowing in the middle branch. So which means at each and every point, that is the current flow. That is the series part of the circuit. And likewise, I2, it is the current flow towards this junction. And I2 is the current flow across 2 ohm resistor here. And the I4, it is the current flow in this branch. So which means across here, 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 that is the same current flow. And likewise, I5, it is the current flow in this actually part of the circuit. So across here, 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 that is the same current flow, that is I5. Now, had it been that it was being given that the current across, let's say, 10 ohm resistor was so. That could be automatically I3. Had it been given that the current across 12 ohm resistor, it is so, automatically that could be I3, actually I1. Likewise, if the current across 1 ohm resistor was given, automatically that could be I4. Now, in this case, the directions are being given, so you follow the direction. But if the direction were not given, if the directions were not given, then you had a humble duty to give the directions on your own. That could be something else. Then you could have had a choice to say, okay, if this is the case, this one will flow this way, this one this way, this one this way, okay? Like this one will flow, actually will go like this, and this one will go like this. That could be okay with you, but that's how you should have to get it. Then let's start. What is the current flow in the first group? It is given as I1, and it is going towards this direction. That is I1. And what is the current flow in group 2? We have, that is I2. That one. It is given as I2. You know, I3 is flowing in the middle branch. Don't think that it is given as don't take it as the current flow in the second group. No, in the second group we have I2 that is flowing. In the third loop we have, you know, how to say, I5 that is flowing. So don't confuse with the current flow in the middle branch whenever you are analyzing your cases here. So I5 is going in this way, that's why we are having it in this way. While this one is flowing in the anti-clockwise direction, that's why we have it in this way. This way, also in the same way. This one is moving in a clockwise direction. So keep that in mind. Now let's start with the analysis in terms of the formulas. That is the voltage. Let's apply the voltage law in each loop. Let's start with loop 1. What is the current flow in loop 1? We have it as I1. Of course, it's not always that in loop 1 we'll have I1. No, sometimes you can have I2. It depends on how you have labeled the current itself, but it doesn't matter. Now, what are the resistors that are found in loop 1? We have 2, ignore the units. We have 2 plus 12 plus 9 plus 10 plus 2. Because we have this, and this as well. They need to find their summation. And that corresponds to have, them as, 2 plus 12, plus 9 plus 10, and plus 2 as well. That is 35. Of course, then minus, out of these given resistors that are found in loop 1, do we have any resistor or resistors that are being transversed by another current in the other loop? Obviously, yes. We have 10. And what is the current from the other loop? We have it as I2. We'll have 10 times I2. Ignore the units. Then another minus, because we also have 2 there. Minus 2 times I2. Then we are done. Then is equal. Now, do we have the source of voltage in that loop? If there's no source of voltage, then it will just be equal to 0. Now we have it as 10 volts partly. Now looking at the properties of the partly, This is negative terminal and this is the positive terminal. So looking at the direction of the current is flowing from negative terminal to the positive terminal. That is the voltage gained, or have it as a positive 10. Upon simplifying, we have 35 I1, and these are like terms, we'll have it as negative 12 I2. That is equal to 10. So this is equation 1. And let's go for the another loop you can have. What is the another loop? We have a loop 2. What is the current flow in loop 2? We have it as I2, of course. And what are the resistors that are found in loop 2? We have 10 plus 2 plus 2, this 2, and plus 1 plus 3. And out of these actually given resistors, do we have any resistors that are being transversed by another current in the other loop, from the another loop? Yes, we have 10 ohm resistor, 2 ohm resistor, 1 ohm resistor, and 3 ohm resistor. So for 10 ohm resistor, we have minus 10 I1 minus 2 I1 minus, now for this one we have it as I5. So have minus I5. Since this is 1, we just have to multiply that one. 1 times I5, it's just I5. Then minus, we have 3 I5. Then it is equal to, do we have the source of battery, actual source of voltages in the loop? Yes, we have this as well as this. Okay, fine. Then let's look at the brightness as well as the direction of the current. So you see that the current, as it is flowing, it enters negative terminal to the positive terminal. That is voltage gained. That is positive 20. And I'll go like that. Negative terminal to the positive terminal, that is another positive 10. Then we'll have plus 10. Then I'll have to simplify that. And what will be that? Let's see. No, we'll have 10 plus 2 and plus 2 plus 1 and plus 3. That is 18. We have it as 18 I2. And these are like terms. That is negative 12 I1, and also these are the like terms. That is negative 6 I5, which is equal to 30. Now this is equation 2. And let's go for the another actually loop. Now in the another loop, we have now loop 3. We have now loop 3. And what is the loop 3? We have the current flow, that is I5. And what are the resistors there? We have 1 plus 3. Always need to add here. Plus 5. Minus, do we have any resistor which is being transversed by the current of the other loop? We have, that is resistor 1 as well as 3. And we have minus I2 minus 3 I2. That will be equal to, do we have the source of power there? We have it as this. Then looking at the products of the battery and the direction of the current, that is from negative terminal to positive terminal, that is voltage drop. That will be given as negative 20. Upon simplifying, we have 9 I5 minus 4 should be I2 is equal to negative 20. Now this is the third equation. Now you need to solve for I1, I2, I3. You need to solve for those simultaneously. Then let's apply the actually voltage current law in the junctions. For the first junction, you can have to see that we'll have I3 entering minus I1 leaving minus I2 leaving is equal to 0. That is the equation number 4. For the second junction, we'll have that of, we'll have I2 entering minus I4 leaving minus I5 leaving is equal to 0. That is equation number 5. So first thing, solve for I1, I2 as well as I3 simultaneously for these three equations. And just have to check on how you can solve those unknown values of the currents. So take note of that. That is equation 1, 2, as well as 3, 4, as well as the 5. So at your own time, discuss with your friends and see how you can operate that one and solve for those I1, I2, I3, I5 simultaneously. Then you substitute into these and solve for the currents on the middle branches. That's how it can be. Mind you, if the directions are not being given, give the directions on your own. But if the directions are given, use the given directions. That would be the best thing. Now, there is another question you should have to understand as well. There is another question you should have to understand. But for instance, before I go for that, sometimes you actually, it's not necessarily that a given loop must look like a window. No. Let's consider this case. Just have to consider it. Let's say this is a part of the circuit of our interest. And let's say we have it in this case. So Strumo, this is loop 1, this is loop 2. Nothing different. Much as it is the closed circuit, it is okay. So keep that in mind. Now let's have to consider this kind of a question. Of course, I'll not solve it for you, but with the concept that we have discussed about in some few examples, you'll be able to solve for this. Let's say we have the circuit and that goes like this. Let's say this is the circuit. And we have it as let's say this is the circuit and we have a switch somewhere here. Let's say this is the switch and we have another resistor here. and let's say this is 10 ohm resistor, and let's say this is 7 ohm resistor, and let's say this is 8 ohm resistor. Let's say that is the case. And now we have the battery. This is 8 volts battery, and let's say this is, we have it as 20 volts battery. Now the question says, how much current flows through each battery or through each resistor, and in these two conditions. First condition, when the switch is open. What would you say? When the switch is open, it means there is no current flow in this part of the loop. So there is no current flow in this part of the loop, in this part of the circuit rather. So which means that is the same as having only this part of the circuit, that you may think of having it as, you may think of having it as just this. You may think of having just this. Now this is 7 ohm resistor, and this is 20 volts battery, and this is 8 volts battery, and this is 8 ohm resistor. You'd have that. So this case will be done using the Kirchhoff's law. That is, let's say the current flow, it is in that direction. Let's say it's given as I. Now you can see this is just a single loop, so we just have to give it as a current without being labeled I1 or I2. Then I will have what is the current flow, that is a current, and what are the resistors? We have a 7 plus 8, and that will be automatically equal to, now let's look at the brightness. Now the current flow, that is negative terminal to the positive terminal, that is a voltage gained. We'll have it as a positive 20. Then we go like that. That is also negative terminal to the positive terminal, that is a voltage gained. We'll have plus, that is 8. Then you'll be able to solve for the current in that way. Then since this is a series circuit, then what I'm going to do is that you know that the current across here is the same current, same and same here. That is another condition. Another condition is when the switch has been crossed. What would you say? So in this case, we are going to use the Kirchhoff's law, so where you now do whatever I've been discussing about. You think of labeling, let's say this is I1, I2 leaving the junction, and I3 going like this. It is okay with you. Now, which means, what is the current flow in I? Actually, in a loop 1, you have 8 plus, 7. Those are the resistors, minus 7 times, what is that, I2, and do the same way we've been discussing. So that's how you should have to understand about the Kirchhoff's laws. That is a junction law as well as the loop law. Thank you. Don't forget to subscribe this channel, and for you to be updated whatever the content that has been created, and that is best for you. Thank you.